So this table summarizes the differences between metals and nonmetals. These are the opposite ends of a spectrum. So in metals tend to be shiny, and nonmetals tend not to be shiny. Metals tend to be malleable, and what that means is that you can hammer them into different shapes. If you've taken anatomy and physiology, you know that the bone in your ear that looks like a hammer is called the malleus. And so that's just coming from the Latin word for hammer. So if it's malleable, you can hammer them into different shapes. You can do that with metals. You can take a chunk of a metal and hammer it until it's long and thin, like a wire. But with nonmetals, you try to hammer them and they just crumble. So like coal, if you tried to hammer coal or something like that, it would just crumble into different pieces. It wouldn't form a new shape like a wire. Metals tend to conduct electricity. Nonmetals tend not to conduct electricity. And metals are all solids at room temperature except mercury, which is liquid at room temperature. So nonmetals are the only things that could be gases at room temperature. So that's sort of a list of different traits that distinguish metals from nonmetals. And just to illustrate the point with being malleable, you could take that wild chunk of copper on the left, hit it with a hammer until it's long and thin, like the copper wire on the right. If you try to do the same thing with a nonmetal, like sulfur, it just crumbles into pieces. So sulfur is not malleable, whereas copper is malleable. In other words, hammerable. Now, this is really a spectrum. And this periodic table is very nice because it color codes the metals and nonmetals, and it shows you how they kind of blend when they get close to each other. So the key is at the bottom here. Everything that's blue is a metal. Notice that's everything on the sort of left side of the periodic table except for hydrogen. And then everything that's in yellow is a nonmetal, so that's hydrogen, and then everything on the right side of the periodic table. Now we do have a third color besides blue for metals and yellow for nonmetals. If you mix those two, you get the metalloids. That's the green here. And metalloids have some characteristics that are like metals and some that are like nonmetals. And it really depends on the element and the specific scenario. But they're called metalloids because they're kind of like metals and kind of not, depending on the case. So it's a spectrum, and it's a rule of thumb thing, and it's a case-by-case basis sort of thing. But in general, you can identify an element using this periodic table based on the color that it has and where it is on the periodic table. Now, if you have a periodic table that isn't colored, note that there should be this solid, darkened zigzag line sort of on the right side of the periodic table, and that separates the stuff that tends to be the metals to the left from the stuff that tends to be the nonmetals to the right. And most of the stuff touching that zigzag line are metalloids, except for aluminum, which is a metal. Okay, so let's practice identifying metals and nonmetals based on particular elements or descriptions of elements. So first, calcium. You go to the periodic table, you see that calcium is over there on the left side. It's blue, so it is a metal, and it checks off a lot of the boxes. It's shiny, it's a solid, etc. So calcium would be a metal. Sulfur. Sulfur is over here on the right side of the periodic table in group 6A, period 3. So that's sulfur, and you can see that it's yellow here, so it is a nonmetal, and it certainly doesn't look like a metal when you see it, that yellow solid. A shiny element, so this is just a description, this isn't a specific element. We could go back to that table we were using, and you could see that metals are the ones that tend to be shiny. The nonmetals tend not to be shiny. So a shiny element would tend to be a metal. An element that is a gas at room temperature, well, we'd go back to that little table, and you'd see that at room temperature, the metals are all solids, except for mercury, but mercury is a liquid at room temperature. So if something's a gas at room temperature, it's a nonmetal. And so that's what D would be. For E, it says located in group 8A. That could also be called group 18. Now group 8A or group 18 is on the far right, and you notice that all of the elements here are yellow. In other words, they're all nonmetals. So it doesn't matter which element you choose in that group, they are all nonmetals. And that would be the answer for E. For 6, it says identify each of the following elements as a metal, nonmetal, or a metalloid. It's the same type of thing. A, it says, what if it's located in group 2A? Or that could also just be called group 2. Now that's over here on the left side of the periodic table. Notice that all of these elements are blue. they're all to the left of that zigzag line. They're all blue, and so they are all metals. And so anything located in group 2A is a metal. B says, what if it's a good conductor of electricity? What is it then? Well, we can go back to our table and we see that metals tend to conduct electricity. And you see that if you've ever seen wires, you see that they're metals. So metals tend to conduct electricity, and nonmetals tend not to conduct electricity. So a good conductor of electricity would be a metal. So that would be the answer for B. For C, chlorine. All right, well, let's see where chlorine is. Chlorine is on the right side of the periodic table in group 7A, period 3. And so you see that that is yellow. It's to the left of this zigzag line. It's yellow, and so it is a nonmetal. And you can see that it's a nonmetal here. It's that light green-yellow gas there. Arsenic. So arsenic is over here. It's in group 5A, period 4. And arsenic is green. So it's right on that darkened zigzag line. It's touching it. And so it's green, and that means that it is a metalloid. It has some characteristics that are like metals, and some that are like nonmetals. It's a metalloid. For E, it says, what if an element is not shiny? Well, if it's not shiny, then we know that it must be a nonmetal, because the metals tend to be shiny, and the nonmetals are not shiny. Okay, what about oxygen? Is oxygen a metal, a nonmetal, a metalloid? Well, you'd go to the top right where oxygen is in group 6A, period 2, and you'd see that oxygen is yellow here. You could also see it's to the right of this darkened zigzag line, so that means it's a nonmetal. And oxygen gas is in the air right now. It tends to be around 19% of the air that we breathe all the time. It's a clear gas, but you can freeze it. Oxygen freezes and becomes a solid at negative 365 degrees Fahrenheit. You can see it becomes this very beautiful, lush blue color. In any event, though, it's not a metal, and you can see that even just by looking at it, but especially by the placement on the periodic table. Nitrogen. Nitrogen is what's in most of the air. 79% of the air we breathe is nitrogen gas, not oxygen. And nitrogen, if you notice on the periodic table, it's in the top right, group 5A, period 2, that capital N, that's nitrogen, and it is to the right of this zigzag line, not touching the line, so it is a nonmetal, and you can see that it's yellow here to represent that. In this picture, this is liquid nitrogen. You can see that it is completely clear. This gas here, the sort of smoke, that's not nitrogen. That's the humidity in the air. When water gets close to the very, very cold liquid nitrogen, the water in the air turns into small, tiny, microscopic ice crystals. And that's what makes up that smoke. But the nitrogen itself is just the clear liquid there. Tin. Now, tin is, the symbol for tin is not T. The symbol for tin is SN. And so the place where that is, it comes from the Latin word stanum. And that is in group 4A, period 5. So that there. We can see that it's really close to the zigzag line, but it's to the left of it, and it's not touching it. None of its sides are touching the line. So that would be a full metal. Tin is a full metal, and you can see that because it is blue here. So this is a droplet of tin. It was molten tin that was dropped into water, and so it froze in the droplet shape that it had when it hit the water. But you can see that it looks very much like a metal. So notice that you can use the periodic table to determine whether an element is a metal, if it's to the left of the zigzag line, except for hydrogen. If it's a nonmetal, if it's to the right of the zigzag line, except for hydrogen. Or if it's a metalloid, which is if the box that the element is in, has a side facing that dark zigzag line, except for aluminum.